Hello, my name is Philipp Weigel. I'm heading a market segment ICR, and with that I'm covering also all the data center applications. And data center is really one of the topics I want to carry you through today. And if you look into a data center, you typically have several challenges. One of the challenges obviously is to get the data in and out, and where we have more and more high-speed links. And to test these high-speed links and have also the PCBs tested, you need high-end network analyzers like the CNB 3000 here, which is among the fastest you will find on the market, especially for production testing and with a very low noise floor. So obviously the connectors is one part, but then if you look more on the higher levels of the communications, we also have solutions. So let's have a look on the next station. Now one level higher or several levels higher, we look at memory interface here, which we interposed here on the card. So this is where we are tapping the signal here. You see we have this four modular probes connected. We have different tips here you can choose depending on the protocol or the interface you're looking at. And then we are tapping directly here on this memory bus. So what we see here is the memory connected via our four modular probes with the different tips. And obviously these tips are depending on which interface you're looking at. And this is now over here connected. And on our RTP, you see here on the one hand side the analog signal. Here you see the DQ write and here the DQ read signal. And you also see down here the decoded stuff, and up here also the telegram. If you would zoom in here a bit more, you would also see the whole data content of the protocol. Okay, coming to our last stop. So we said we have now the data connection. We got the data through the connectors. We looked at the physical and the logical layers. And another thing is these chips draw a tremendous amount of power. If you think of the latest NVIDIA chips, they have hundreds of amps going over the PCB. And if you have hundreds of amps over a PCB, you care to look at many lines. So this is an oscilloscope, a faceless oscilloscope in this case, which you can also couple with our MXO series to have more channels, but here in this demo we only have a faceless demo. On the one hand, you can obviously just couple it with a normal oscilloscope and then have 16 channels, for example. But on the other hand, it also enables you, if you're on a desk environment, to just connect the screen and have more space on your desk you can use for your setup. On the other hand, obviously, some of the applications are more in the production environment where you have it in an ATE system integrated and you really care for rack space and just do all the remote interface operation of the instrument. But also here, you can just copy one-to-one the commands from the standalone unit of the MX05C and reuse it here. So that makes it really easy to develop your remote scripts. But in the end, you care for looking at all the different lanes going to the chip and look at the power integrity. Have the lowest ripple and noise on these chips. So to analyze the power management ICs and the chip. And these oscilloscopes with the 12-bit of resolution really support you here.